Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2017, problem number 21. The problem says that let x1, x2, x3 and x4 be a random sample from normal theta 1, comma sigma square distribution, and y1, y2, y3, y4 be a random sample from normal theta 2, comma sigma square distribution, where theta 1 and theta 2 are real numbers and sigma is greater than 0. Further, suppose that the two random samples are independent. That means these samples x1 through x4 and y1 through y4 are independent random samples. For testing the null hypothesis, h naught equals to theta 1 equals to theta 2 against the alternative hypothesis h1 theta 1 greater than theta 2. Suppose that the test psi rejects h naught even only if summation xi I running from 1 to 4 is greater than summation yj j running from 1 to 4. The power of the test psi at theta 1 equals to 1 plus root 2 and theta 2 equals to 1 and sigma square equals to 4 is, so basically we need to find the power of this test at these points theta 1 and theta 2 and sigma square equals to this. See, the random sample x1 through x4 has been, this is basically, so x1 up to x4 follows IID normal theta 1 comma sigma square, and y1 through y4 follows IID normal theta 2 comma sigma square. Just writing down the basic problem here, just without all those paraphrases and all. So h naught says theta 1 equals to theta 2 versus h1 says theta 1 greater than theta 2. So basically the parameter space is actually comprises of the entire R2, right, in general, but h naught says that the theta 1 equals to theta 2. That means the parameters, the null parameter space is basically the line y equals to x, right? And the alternative parameter space says that the line is the parameter space is above the, sorry, below since theta 1 is greater than theta 2, below the line y equals to x, this thing, right? This, so rejects h naught, the test rejects h naught even only if the sum of the xi's is greater than the sum of the yi's, right? It is given. So the power of the test is actually nothing but probability under h1 rejecting h naught, right? So under the assumption that h1 is true, we have to reject h naught. The probability of that is actually the power of the test. Now the rejecting h naught is nothing but summation xi greater than summation yi, right? Now h1 contains all those ordered pairs of theta 1 and theta 2 such that theta 1 is greater than theta 2, right? So among all those points we have to calculate the power of this test at this particular values. Theta 1 equals to 1 plus root 2 and theta 2 equals to 1 and sigma square is given to be 4. See, here 1 plus root 2 is greater than 1, right? So it actually is this thing, this theta 1 and theta 2 for this particular value, this actually belongs to the alternative parameter space because theta 1 is greater than theta 2, right? So it's fair, it's valid. Now x1 through x4 follows IID normal theta 1 comma sigma square. Therefore summation xi follows normal 4 theta 1 comma 4 sigma square, right? They are IIDs. So this summation xi follows normal 4 theta 1 comma 4 sigma square. Now therefore, now theta 1 is nothing but, here in this particular assumption theta 1 is 1 plus root 2. So this summation xi follows normal 4 into 1 plus root 2 comma 16, because again sigma square is given to be 4, so 16. Similarly, summation yi follows normal 4 theta 2 comma 4 sigma square, again just the same logic. Now again here theta 2 is 1, here theta 2 is 1, so summation yi is nothing but normal 4 comma 16. Now this summation xi minus summation yi is actually nothing but normal 4 root 2 comma 32, because we have already found out that they follow normal, and just the difference of that also follows normal, right? Because linear combinations of normal random variables also follows also follows normal distribution, right? So this thing, this entire thing, summation xi minus summation yi follows normal 4 root 2 comma 32. So standardizing this, that means summation xi minus summation yi minus 4 root 2 divided by 4 root 2 is actually nothing but standard normal, right? This thing. Now coming back to the problem, the power of the test at the given values is probability under h1 summation xi greater than summation yi. Just standardizing this, just that means just deducting summation yi on both sides and then standardizing. So basically summation xi minus summation yi minus 4 root 2 whole divided by 4 root 2 is greater than minus 1. Now this thing is nothing but z, because this is standard normal, so we can call it z. So this is nothing but probability z greater than minus 1, right? Which is 1 minus probability z less than equals minus 1, which is nothing but 1 minus phi of minus 1. Again this phi of minus 1 can be written as 1 minus phi of 1. So this is nothing but phi of 1, which is given to be 0.841. 0.13 from the question paper. It's given in the question paper, so not a problem with that. So the answer is 0.8413, right? Very easy, very easy. Yeah. So this one, option D is the answer. Very easy problem, right? Just have to find how to you have to know the definition of the power of the test, how to calculate the power of the test. That's it. Very easy. So yeah, there you have it, the solution to this problem. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.